Hello, everyone. I want to talk a little bit about Newton's three laws of motion. Law one is what's known as the law of inertia. That states that an object at rest will remain at rest unless acted upon by another force. It also states that an object in motion will remain in motion unless acted upon by an outside force. So basically, if an object is stationary, not moving, or if it is moving at whatever acceleration, speed, velocity it's going at, the object's tendency is to remain in that state, whether it be not moving or moving, unless acted upon by an outside force. We take this tennis ball here, and as I apply force to it with my hand and it goes across the paper and across the table here, I've applied a force to it. Its tendency is to continue moving. Now we know there are several forces that are resisting this movement or motion. One of them is friction between the ball and the paper or the ball and the table. That friction opposes motion and is slowing it down. Specifically, this is rolling friction. Another one is gravity's pulling this ball down through the table, slowing it down as well. Another is air resistance. So again, the law of inertia states, which is Newton's first law of motion, an object at rest will remain at rest unless acted upon by an outside force. An object in motion will remain in motion unless acted upon by an outside force. Let's talk about Newton's second law of motion. The second law states the force acting on an object is equal to the mass of that object multiplied by its acceleration. So if we put that into context, again, Newton's second law states the force of an object is equal to the mass of that object multiplied by its acceleration. As you can see right here, we've just put this in formula format. F would be force, it's capital F. Lowercase m is mass, and then lowercase a is acceleration. Now, anytime you're trying to calculate this, it's going to be important to remember the proper units. Force is measured in newtons, capital N. Mass, kilograms in this particular situation. And acceleration is meters per second squared. Now, one handy conversion to keep in mind is the following. 1 Newton is equal to 1 kilogram / meters / second squared. So keep in mind when you're doing this, mass needs to be in kilograms. Sometimes you see it in other units like milligrams or grams and things like that. But for it to be converted to measuring a force and measuring newtons, has to be in kilograms. Acceleration, similar concept there. Acceleration is meters per second squared. And if you don't remember how to calculate acceleration, it's velocity final minus initial divided by time. So again, that's Newton's second law. The force acting on an object is equal to the mass of that object multiplied by its acceleration. Now for Newton's third law of motion. It states for every action, there is an equal and opposite reaction. So what we have in front of us is what's known as a Newtonian demonstrator, which actually gives us a good example of Newton's third law. Every action, there is an equal and opposite reaction. So if we take this left metal ball and pull it back, this is the action. The equal and opposite should be that 1 should come out over here. The interesting thing about this is, as with any law in science, you can change certain conditions for testing purposes, but the end result will be the same. So we will do that with this here. We just took 1. This time we'll take 2. So again, Newton's third law, for every action, there is an equal and opposite reaction. So we should have 2 going to the other side. Let's take it a step further. Let's take 3 back. We'll do this here. So by doing so, the equal and opposite would be 3 going to the other side. Let's test this out. Do that a little better. Let's change the parameters again. Let's go 4. Let's do this in a different way. Let's take both the right and the left metal ball and pull them back. Again, since this is a law of science, the conditions, you can change the conditions, but the result will be the same. So, for every action, there's an equal and opposite reaction. Again, let's do it with 2. Now, lastly, this is always interesting. People kind of look at this and kind of wonder, but again, just apply it to Newton's third law. For every action, equal and opposite reaction. We hope you enjoyed this video about Newton's 3 laws of motion. We will see you again soon.